Hey everyone, I'm Max, and today I'll be giving a short demo of some of our recent work on dynamic benchmarking for NLP, for natural language processing. So traditional research benchmarks like MNIST, ImageNet, Squad, SNLI, Glue, etc. These are great because they make it quick and easy for us to compare performance of different systems against each other. But the status quo is starting to show some cracks now. Traditional benchmarks are static. They have various artifacts they can be overfit to, and they can saturate quite quickly. While it took us around 18 years to reach human performance on MNIST, it took us less than 1 year to achieve human performance on the Glue benchmark. And this is commonly referred to as the benchmark being solved. And today I'll be giving a demo of DynaBench, and I'll be using question answering as a running example for the remainder of this talk. So what is question answering? Quite simply, question answering is the task of finding a span of text in a passage that answers a question. So here we can see that for this passage about the UCL NLP inaugural meeting, and the question, who is giving the talk with Sebastian Riedel, the answer was in fact Tim, who will be speaking after me today. So this is pretty impressive that the model seems to be able to answer these complex questions. And we also, back in 2018, surpassed human performance on Squad, which is kind of the main benchmark for question answering. And so QA now is solved, and as you can see in kind of these kind of articles, robots can read better than humans. What I hope that I will convince you today is that this is in fact not the case, and that we still have quite a long way to go. So in this example here, for example, once you start to ask slightly more complex questions, the model starts to struggle. And I'll be using one of the best ways I know, at least, for truly testing systems beyond static performance metrics, which is interacting directly with them. So DynaBench builds on this work BDI carried out here at UCL in collaboration with Alistair Roberts, Johannes Velbel, Sebastian Riedel, and Pontus Stennetorp. And what we aim to do in this work is to collect questions in state-of-the-art question answering systems found challenging to answer. So the annotation process looks something like this. We basically paired a human and a state-of-the-art reading comprehension model in an interactive setting. So the human is given a passage, and then they have to generate a question and select an answer for that question from the passage. This passage and question tuple gets sent to the model, and the model predicts its own answer for that question given the passage. Then we calculate the F1 score, and the F1 score is a metric which measures how accurate the answer is compared to the model's answer compared to the answer selected by the human. And if the F1 score is greater than some threshold, in this case we used 40%, we consider the human to have lost. And the human loses means that they haven't managed to successfully beat the model by asking a complex enough question that it couldn't answer. And so the human tries again, edits the question, makes changes, changes the question completely, etc. If the human wins, so if the human asks a question that is adversarial, so that the model can't answer successfully, we collect that example and we use that as part of our data set. So we collect quite a bit of data. We collected something like 36,000 examples in this work. And here you can see a bit of an interactive example of what that process looks like. So the human is asking various questions, selecting answers from the passage, and then submitting those to the AI, to the QA model, to see whether or not it gets the answer correct. As you can see here so far, the human finally managed to beat the model. So we made various interesting findings in this work, and I encourage you to read the paper. But one of the key takeaways that I would like to highlight is that through this process, we collected a very diverse set of questions, and they required a much broader set of comprehension skills in order to answer than traditional benchmarks such as Squad. So if we look at the chart here, for example, you can see that Squad has very few questions requiring, say, multi-hop reasoning or temporal reasoning, and in fact, no numeric questions or questions involving negation. Whereas as the model in the loop, so as the model that the humans are trying to beat gets harder, the diversity of the questions actually increases, and you need a more diverse set of question types. And what we also observed was that as questions got more complex, to answer a single question, you might even need multiple types of reasoning. Say you have multi-hop reasoning with negation. So that brings us to DynaBench, and DynaBench is a research platform for dynamic benchmarking and evaluation. And this was built as a collaboration between Facebook AI, Stanford, UNC, and us here at UCL. And so the interface looks very similar. So the work I just presented is the first round of the QA task in DynaBench. And what I'd like today is take around 5 to 10 minutes to demonstrate the platform and get you to try it out and try and come up with questions that fool the model. And what you should ideally be looking for is patterns of questions that the models struggle to answer. Say, I don't know, you use certain types of negation, or if you depend on co-reference, or just try to come up with complex questions that you think the model won't be able to answer. And one thing I should point out is all the examples you will be trying out today are on passages which the model has never seen before. They're from Wikipedia, so they're from the same domain that the model has been trained on, but they're not passages that the model has ever seen before. And if you notice any interesting patterns, please post them in the chat while you're trying things out, and we can have a bit of a discussion going. Okay, so I will jump quickly to DynaBench. So this is what the question answering page looks like. We're currently at round 3. You can see the leaderboard of the models. This is the electoral large model. It's the one we're going to be trying to beat. And so what I encourage all of you to do is go to dynabench.org/task/QA. You can create an account if you want to. It takes a couple of minutes to sign up. You don't have to. You can play directly in the sandbox. And once you set up, click Create Examples, and that will load a passage from Wikipedia. And basically take a few seconds to read the passage, and then you can ask questions such as, in what year, this part of the demonstration is live because the passages are selected at random. So in what year did Wilhelm Meister's apprenticeship get published, I guess. And that will be here, and I put a typo in the question, but hopefully the model should be able to, with a few typos actually. Oh, so I managed to fool the model. I'm not sure this is a completely valid question, and try and retype it properly. So in what year did Wilhelm Meister's apprenticeship get published? Okay, so if I type it correctly, the model predicts 1796. But if I have a few typos, the model gets it wrong. So actually, this might start to suggest that maybe there might be some pattern here. That if I mistype things slightly, and I think that's fair game. It's probably representative of what natural questions might look like in the real world. Then maybe I might be able to confuse the model a bit more. Okay, so let's take 5 to 10 minutes. If anyone has any trouble with accessing it, please let me know. And yeah, keep me posted in the chat, and I'll give you around 5 minutes to interact with the model in various ways, and I'll be answering questions as we go. One other interesting thing which you might want to try out while interacting with the model is there's also this inspect button over here. So if you click that button, doesn't seem to be working at the moment. Okay, forget about that. That will basically give you word level importance scores for the tokens in the passage and how the model is treating those, and also those in the question. But it seems we have a small technical issue at the moment. If anyone has any questions in the meantime, please feel free to post them in the chat, or yeah, or in the Q&A section, I guess.
Somebody's raised their hand. I don't know if they have a question. Can you put it in the Q&A? If there are no questions, we will start the next presentation at 12, which will be the last presentation before lunch break. Thank you, Max.
Oh, so I'm not.
Oh, there is a question. Hi, Max. I was wondering what will happen when multiple questions are asked.
So if you combine questions into one, like if you combine multiple questions into one, or if you ask many different questions. I'm not sure if I understand the question. When multiple questions are asked. So I mean, if it's a set of different questions, then the model will answer those one by one. But one interesting you can do is multi-hop questions. So essentially questions where they're combined in a sense. So it's one question requiring many pieces of information that the model needs to process in order to answer. So that's quite an interesting way of trying to trick the model.
Thank you.
Okay, so I guess you've all had some time to play around with it a bit and to try to fool the model. I will now quickly go back to the presentation, and so there's also access to the data on Leaderboard, so you can download this data, you can use it yourself to train your own models, and you can see the Leaderboard for the current best models on these data sets. And there are lots of things you can do with this data. One thing that we've managed to do recently is improve model robustness in various settings, such as adversarial robustness, domain generalization, reasoning skills using checklists, and also indirect competition with humans in an adversarial human evaluation setting. And so what we did is we basically, so this is work which has just been accepted to MLP 21 in collaboration with Facebook AI Research. And what we did is using the collected adversarial data, we used a combination of different AI models to generate difficult questions, and then process those questions, label and refilter those questions until we come up with new sets of synthetic question answer pairs. So we have an example here, such as when did Old English begin to be used? And the answer is 5th century, after various steps of processing. And what this synthetic data set allowed us to do is to get performance improvements on the adversarially collected data, so on the kind of data that you were just trying to create. But much more importantly, at least for me, is this last column here, this macro averaged validated model error rate. And this is basically a percentage of how many questions people ask the model. Of those questions, how many of them are adversarial, so how many of them successfully beat the model. And before we use the synthetic data, we have around 20 and 17%. But once we include the synthetic data, we also, so that model error rate drops quite substantially, and it becomes much harder to try and beat these models. And in fact, the QA model you were just trying to beat has been made more robust using this approach. Okay, fantastic. So that's all I have for you today. If there are any questions about this work, please let me know. Thank you for listening and participating. If you'd like to learn more, don't hesitate to get in touch. Feel free to follow us on Twitter if you want to be kept up to date on what we're doing. And if you have any questions or observations you'd like to discuss, please either post them in the chat or raise your hands on Zoom or however we're taking questions. Thank you.
Yeah. If you stop sharing your screen, you can then probably see the Q&A. There's a few questions from Suraj.
Fantastic. I apparently fooled the model, but I'm not sure how. That's a good question. I'm not sure either. So that's an interesting point, though. Sometimes you'll notice certain patterns of when you fool the model, but the model, in most cases, won't learn a skill completely. You know, it might be able to handle, say, 80% of numeric questions, but another 25% it might find quite challenging, and it might not always be quite obvious as to why that is. So that's, oh, it predicted 8, but the person would say 8. Okay, in that case, it seems like we have a small problem with the automatic metric. And then it looks like an extra space, so it would be 8. Oh yeah, that's a good point. So that doesn't happen in the crowd sourcing interface. We had a recent change where we updated all the models last week, so there are some slight changes to the metrics. But that's so in that case, the model would be considered correct in the validation stage. But excellent question, thanks, Suraj.
Okay, I guess if there are no more questions, we will pause until 12 when we'll have Tim with his presentation. Thank you.
Thank you very much, everyone.